Hello, in this video I am going to explain how we can choose the equation of motion to solve one dimension motion problem. So let's go back and look at equation of motion at first. So there are three equations of motion you can see over there. I wrote over there on the top. And there are five different physical quantities: v, initial velocity, v naught, final velocity v, time of travel t, acceleration a, and displacement, which is delta x, also written as x minus x naught, the difference of final position and initial position. So all among these five physical quantities, every equations are related between four quantities. So to solve the problems, here I wrote general strategy. So first one is you have to make a sketch a problem, so which is easier to understand. Next one is write down the given values, whatever given, with symbol and sign. So you have to care about the sign. Sometimes it might be positive and negative. I'll tell you in next problem how to deal with this sign. Next one is to use this equation, you have to have at least three quantities given. So if you are not three quantities given, you have to find out there is something missing information, and at least three quantities should have to be known, and identify what is asking. So three quantities are known and what is asking. So there are four different quantities. So you can look at every equations are related, but there is relation of four different physical quantities. So you can choose that equation which three quantities are known and one is unknown, which you have to calculate. That way you can choose equation. Now before starting problems, something you have to remember, and something is hidden in language and problems, so just like that. So I'm summarizing in 4 points over here, like just this, like this. If a body starts from rest, means its initial velocity is 0, so it's at rest initially. Same thing, if a body stops, it means the final velocity is 0. Similarly, if a body is moving with uniform velocity, then its acceleration is 0. Means uniform velocity means there is no change of velocity. Velocity is constant. So acceleration is rate of change of velocity. So if there is no change of velocity, means its acceleration is 0. And same thing, if there is a negative acceleration, means the body is retarded. Means its final velocity is less than initial velocity. This means it's continuously decreases its velocity. So let's go back and look at the problem. So in this problem, a car is traveling north at 17.7 meters per second. And after 12 seconds, its velocity is 14.1 meters per second in the same direction. So look at here, in the same direction. And we have to calculate, find the magnitude and direction of car's velocity. So for the first step is, you have to draw the sketch. So I took north is up direction. So the car is traveling north, okay? Car is somewhere over here at point A. So initially its velocity is v naught, which is 17.7 meters per second given, and it is traveling north. So I'm taking north is positive, so v naught is also positive. So it travels until 12 seconds, and after 12 seconds its velocity is v, which becomes 14.1 meter per second. Now it is same direction, so it's along north direction, so it's also positive. Now next thing is we have to calculate acceleration, its magnitude and direction. So we have v naught, initial velocity, time of travel t, final velocity v, and we have to calculate a. So three quantities are known, one you have to calculate. So if you look at this four quantities, which equation is related? look at here, the first one, v is equal to v naught plus at. So this v naught, t are given and a is unknown, so you can use this equation, first motion equation, my equation sheet. V is equal to v naught plus at. So substitute this value, v is equal to 14.1 is equal to v naught is 17.7 plus a is unknown and t is 12. So solve this. 14.1 minus 17.7 is equal to 12 times a. So a is equal to 14.1 minus 17.7 divided by 12. I'm using my calculator. 14.1 minus 17.7, which you can get 3.6. 17.7 is negative, so you can get negative sign in front, divided by 12. So if I divide 3.6 divided by 12, then I'll get 0.3 meter per second square. Acceleration is meter per second square, its unit. You have to substitute back the its unit, and here is negative sign also. Okay, now look it back. So what is its magnitude? So acceleration is magnitude is 0.3 meter per second square. And what is its direction? Look at this negative sign. So I told earlier, this negative sign actually determines what is the direction. So I am choosing north direction is positive, so this negative means it is acting towards south. So the acceleration is acting towards south direction, opposite the direction of velocity. So that's why its magnitude is 0.3 meter per second square, and its direction is opposite to the direction of velocity, or along south direction. So which also makes sense because velocity is decreasing. Initial velocity is 17.7 meter per second, final velocity is 14.1 meter per second. Is decreasing, so it means it is retarded motion, so it means its acceleration is negative.